as opposed to something that will be tested in this course. What you need to know in this course is this material here. So the notation we use for the binomial coefficient is brackets with n and k one above the other. And we commonly write this also as a big C with a subscript of n in front and a subscript of k behind. And we often, so this is the n, this is a combination equation. We often say n choose k because we are starting with n possible choices and choosing k of them. So from our combination from the previous notes, from the mini lesson, so see mini lesson on combinatorics. For background. So we are using n factorial divided by k factorial and divided by n minus k factorial. So if we look at example 3 again, what we did in example 3, if we look at the probability of x equals 3, we have had a coefficient was 4. So our n is 4 because we had 4 flips of the coin. K equals 3. We're wanting 3 of them to be heads, and we're looking at how many different ways could we get 3 heads out of 4 flips. So we would write 4 choose 3 equals 4 factorial divided by 3 factorial times 4 minus 3 factorial. Now, 4 minus 3 factorial is simply 1. So this now becomes 1. 4 factorial over 3 factorial. Well, 4 factorial, remember, is 4 times 3 factorial. And those would cancel out, so our final answer is 4, which is what we got, what we originally had. So we can see from that example that the coefficient does work. And just to go back up, okay, you can verify from our total list of outcomes that we have this many of each value, number of heads. So you can go back and check those yourself. So you do not need to be able to work this out by hand. You should understand where it comes from, but you do not need to be able to work it out. You do need to be able to use your calculator to find the coefficients. And to do that, you would enter your value of n. So in this last example, 4. Then you would choose math, not num, but rather PRB. And then choose from the list NCR, and then write in your value of R. So in this case, a 3. So this would be a good time to stop and make sure you know how to use your calculator for that. All right. So how do we go about using this? If x has the binomial distribution with n trials and a probability p of success on each trial, the possible values of x are 0, 1, 2, 3, etc., all the way up to n. If k is any one of these values, then the probability of x being equal to k equals binomial coefficient, and choose k, of p to the k times 1 minus p to the n minus k. And remember, nk means the same as ncr. K, sorry, not r. We'll use k in these notes. Now we can verify that this works for our last example. And you'll see, we'll look at the x equals 1 situation here. There's the probability of heads, and we have one head, which is k, and a 1 would be here. 0.4 is the probability of not heads, and 4 minus 1 equals 3. And we'll look at the mean and standard deviation of a binomial distribution. So for example 4, a student writes a 5-question multiple choice test by guessing on each answer. Each question has 4 possible answers, and we will assume that there is independence of guesses. So we're going to use the binomial probability model to find the distribution, to find the probability distribution of x, where x is the number of correct answers on the test. So the way we will do that is as such. Probability of x equals 0 is 5 choose 0 of 0.25 to the 0 times 0.75 to the 5. And when we work that out, we would get 0.24. Now I would like you, so we'll fill that in here, and then you're going to do the same sort of work for the probability of x equals 1. So in that case, I'll write this one out. So it would be 5 over 1 times 0.25 to the 1, 0.75 to the 4. And so on. We will increase the exponent of the first term by 1 each time and decrease it for the second term each time. So go ahead and calculate those, and we'll come back. So you should have gotten 0.40, 0.26, 0.09, 0.015, and 0.001. So we're being asked to make a histogram of our probability distribution and to describe what we see. So once again, you should go and do that on your own as a practice, and then come back and see if you got the same thing that I did. Alright, so your histogram should look like mine. And we're going to look at, remember, socks. So the shape is skewed right. And it's unimodal. And center, the mean is between 1 and 2. And so what would we expect the mean of x to be? Well, it's going to be b. Well, we would have the probability of each one being successful is 0.25, and we have 5 trials, so we would get a 1.25. And so we would expect our answer to be about 1.25. So now we're going to calculate the mean and standard deviation for x using the calculator. And so we are going to put into L1 the values of x, and into L2 the values of the probability of x. And we're going to use 1 var stats, and we will end up with the mean being 1.23 and the standard deviation of 0.95. So this is not quite 1.25 because of rounding in our probability distribution. Is not quite, 1.25 because of rounding in the probability distribution.